Hello, everybody. Um, Welcome to the LMS initiative taken by Department of Collegiate and Technical Education. Myself, I'm Dr. Basha, working as professor and head Department of Civil Engineering, Government Engineering College, Hassan. Today, I'm going to present you a module 5. In the module 5, I'm going to take up the session 1. As you know, in the module 4, uh, we have discussed about the secondary wastewater treatment, um, especially trickling filter and then activated sludge process. And we also have discussed about the rotating biological contactor. Then we discussed about the pond system, um, these things. And in the secondary wastewater treatment, as you know, it deals with removal of organic dissolved solids which are present in the wastewater. If you check the quality of wastewater which is coming out of the secondary wastewater treatment, still it has got some, the wastewater has got some the materials in it which are not good for the receiving waters. For example, the phosphates and the nitrogen compounds is will be high in the effluents of secondary wastewater treatment. So that has to be again polished before throwing it to the nearby river. So in this module 5, uh, we are going to understand the advanced wastewater treatment because see nowadays because of the scarcity of water, the reuse of wastewater has become a trend. So, if you want to reuse the wastewater for other purposes, um, most of the pollutants which are present in the wastewater has to be removed. It has to be removed. Then only we can reuse it. So, in this the module 5 in the session 1, we are going to discuss about why advanced wastewater treatment is needed and what are the treatment options which are available, and we are going to discuss about biological nitrification and denitrification also, and phosphorus removal. Coming to the need of advanced wastewater treatment, why the treatment advanced wastewater treatment is to be done for a wastewater or for an effluent coming out of a secondary wastewater treatment. Advanced wastewater treatment is also called as tertiary treatment. Tertiary wastewater treatment may be provided to the secondary effluent for one or more of the following contaminant. Further, why it has to be done? The number one is to remove the total suspended solids and organic matter those are present in the effluent after secondary treatment. If you check the quality of effluent coming of secondary wastewater treatment, that is from trickling filter or from the activated sludge process, it may have some amount of suspended solids and it may have some organic matter which have to be removed before disposing the effluent to a nearby river. So that is one of the reasons. And to remove specific organic and inorganic constituents from industrial wastewater, from industrial effluent to make it suitable for reuse, to make treated wastewater suitable for land application purpose or directly discharge into the water bodies like rivers, lakes, etc. See, if you dispose the secondary wastewater directly to a river or a lake, listen, it has got phosphates, it has got nitrates. Definitely, these are the nutrients, and these nutrients will activate the algal activity in the water and results in eutrophication. So to avoid all these things, definitely those things has to be removed, which is done in the tertiary treatment. That is what I said. To remove residual nutrients beyond what can be accomplished by earlier treatment methods. You cannot remove all the nutrients in the secondary wastewater treatment. It has to be done in the tertiary treatment or the advanced treatment. And there may be a presence of microorganisms which are not helpful to the human beings, or disease causing microorganisms which are called as pathogens. So that has to be removed. In the secondary treatment, it is not removed. So in the advanced wastewater treatment, uh, the pathogens are also removed. And to remove the total dissolved solids, to meet the effluent standards, because most of the countries and most of the states has got their own the quality standards. To meet that quality standards, advanced wastewater has to be done. So these are some of the reasons why advanced wastewater treatment is to be done. Basically, removal of nutrients like nitrogen and phosphates, and removal of some uh, the removal of total dissolved solids, then killing of pathogens are the main need for advanced wastewater treatment. See, I'm giving you a diagram. What are the different treatments options that are available in the advanced wastewater treatment? Primary treatment is done. Once the primary treatment is done, it is taken to the secondary treatment. To recall, in the secondary treatment, it is the removal of dissolved organics which are present in the effluent of primary treatment. What we do generally, the advance once the secondary treatment is done, and so the wastewater is not easily or just thrown into a nearby river lake, because it has to be checked. And nutrient, if the nutrient present is there, if the pathogens are there, definitely it has to be treated. So the advanced treatments that are generally done to the sewage are nutrient removal, means removal of nitrogen and phosphorus. Disinfection, disinfection is nothing but killing of pathogens or microorganisms which are present in the sewage. Nitrification and denitrification is nothing but the conversion of nitrogen. Ion exchange, it is used to remove the solids which are present in this one, and even the membrane process also, filtration also, and adsorption also. So these are some of the options which are available for the advanced wastewater treatment. Coming to the nitrification and denitrification, the question arises: why nitrogen is to be removed from wastewater? It is, as nitrogen, is a nutrient. Definitely, it will help the plants that are present, aquatic plants that are present in the stream. Understand? And it will help the algae also. Understand? So, to improve the receiving stream quality, nitrogen is to be removed. And if we throw the water directly to a nearby uh, the river or on the ground, definitely the groundwater is going to be contaminated by nitrates. And as I said, to avoid eutrophication of lake, to increase the suitability for reuse, nitrogen is to be removed from the wastewater before discharging it onto the ground or to the stream. What exactly is nitrification? See, mm, in the slides you can see ammonium is NH4. Understand? In the nitrification, what happens is ammonia is going to mix with the oxygen to form nitrate, NO2. Understand? Then this nitrate is going to add to oxygen to form nitrate. This is the process of nitrification, from ammonium to nitrate. First to nitrate, then to nitrate. So in the nitrification, the first step is ammonium is going to be oxidized to nitrite and hydrogen and water. This is a bacterial reaction or an activity that happens in the presence of bacteria called as nitrosomonas. And then the product that we get, that is nitrate, In the second step, are oxidized to nitrate with the help of nitrobacter. So overall reaction is NH4 plus 2O2 gives you NO3 plus 2H plus H2O. That means ammonium is converted into nitrate. So nitrates, as you know, nitrates are removed by. Then what is denitrification? See, in the nitrification, the ammonium, one form of nitrogen, is converted to nitrate and nitrate. Still, that nitrates are in the can be reduced to finally to the nitrogen gas, which is an inert gas, which is not going to, which will escape into the atmosphere without having an impact to the water. So, denitrification is the reduction of nitrates. Nitrates are the final products of nitrification back into the largely inert nitrogen gas, completing the nitrogen cycle. So, the denitrification process again, that is also a bacterial based activity. The nitrates are converted into nitrogen gas. This process is performed under anaerobic or the anaerobic conditions by facultative heterotrophic bacteria commonly found in the wastewater. Here, nitrates are removed by two mechanisms. One is the conversion of nitrate to nitrogen gas by bacterial metabolism, and conversion of nitrate to nitrogen contained in cell mass, which may be removed by settling. Denitrification occurs when the oxygen levels are depleted and nitrate becomes the primary electron acceptor source for microorganisms. And coming to the phosphorus removal, phosphorus are another nutrient that are present in the wastewater coming out of a secondary wastewater treatment. Phosphates and nitrogens are generally not removed to the to what we require for disposal of the wastewater into the nearby river. So there will be an excess of phosphates. Excess of phosphorus is discharged in the final effluent, causing eutrophication of lakes. Eutrophication of lakes means the development of plants and algae in the lakes and covering the whole lake with these the weeds and natural bodies. Generally, it appears as orthophosphates, polyphosphates, and organically bound phosphorus. The phosphorus are present in orthophosphate form, polyphosphate, and organically bound phosphorus. Phosphate removal is currently achieved largely by chemical precipitation. So we use chemical precipitation. We have been using, and when we say it's a chemical precipitation, which is generally expensive and causes an increase when the precipitation happens. Understand, whatever the bottom the precipitate, what we are going to get, what we call it as sludge. Understand, it will increase by an up to volume of 40%. So the researchers started thinking about an alternative to this the chemical precipitation. So they developed a process called an alternative is BPR, biological phosphate removal, which is a microbiological the activity, the reactions. This removal of phosphates happens in the presence of microorganisms, which is accomplished by sequencing and producing the appropriate conditions in the reactor. See, in the chemical precipitation, what happens? See, we have studied about the mm, flocculation, then coagulation in the water treatment. Understand? Here also, we are going to use a coagulant. This coagulant is going to react with the phosphate to form a precipitate, and precipitates are going to, because of the heavy nature of the precipitate, it is going to settle down, and we are going to scrap it. And as I said, when the precipitate settles down, and the volume of the precipitate will be very high, and if we uh, use it, the chemical precipitation for the removal of phosphates, understand, we are going to end up with lot of sludge, which is really difficult to dispose it. So phosphorus in the removal mechanism, metal salt, the aluminum sulfate, what we call it as alum, is used, and it is going to be dosed with, it is dosed to a wastewater which has got the phosphates, and it reacts with Al2SO4 thrice 18H2O to form AlPO4, which is a precipitate which settles down, and the acid, sulfuric acid, is formed, and H2O. Then we can add FeCl3 also, and another the metal salt. It reacts with phosphates to form FePO4 plus HCl3. See, the chemical treatment, in the chemical treatment, sludge is produced, which is really difficult to handle because of the huge amount of huge amount. Understand, there will be a depletion of the alkalinity, pH is decreased, and the total dissolved solids is increased. See, so these are some of the problems we are going to encounter when we use chemical precipitation. Large amount of sludge, the alkalinity is depleted, and the pH is decreased, and there is an increase in the TDS when you use a chemical precipitation. The mechanism is simple. Alum is added to the wastewater which has got phosphates. Aluminum phosphate is formed. FePO4 is formed. Understand? They are going to settle down, take it out, but disposing that sludge is a tough task. And if you check the quality of wastewater that is coming out of the chemical precipitation, definitely there is a decrease in pH, and the alkalinity has come down, and there is an increase in the TDS because of the addition of chemicals. So, because of this, the researchers have started thinking about finding out a new process. So, a new process has come out, which is called as, sorry, before going to that one, let me show the chemical process removal flow chart. And here, the wastewater, which is the primary clarifier, is used, and the secondary treatment is done. When the wastewater which is coming out of the secondary treatment definitely has got these orthophosphates, and that has to be removed, which what we call it as advanced wastewater treatment. Here, we are going to add metal addition, and that metal addition, when it is added, understand, coagulation takes place, and in the secondary clarifier, we are going to um, coagulate it, and it settles down. Understand? This is the general flow chart of a chemical phosphorus removal. So, as I said, the chemical precipitation method for phosphorus removal is an expensive process, and it ends up in large production of sludge, which is really difficult to handle it and dispose it. So, a new process has come up into picture, which is called as enhanced biological phosphorus removal, EBPR or BPR. This is not a chemical process, it is a biochemical process or a biological process that happens in the presence of microorganisms. Biological process that promotes the growth of phosphorus accumulating organisms that are able to take up and store high concentration of phosphorus. Normally, bacteria inactivated can contain 1 to 1.5% of phosphorus. In the EVPR process, bacteria that store phosphorus are selectively retained in the biological process, and they contain about 20 to 30% phosphorus. So, they're going to use phosphorus accumulating bacteria which accumulates more phosphorus in it. For this, there is a need for an anaerobic aerobic process to select for these PAOs, phosphorus accumulating organisms. Phosphorus accumulating organisms require readily biodegradable COD as volatile fatty acids. Denitrification bacteria outcompete PAOs for RBCD, need anaxic zones for denitrification if nitrates are present. Supplemental carbon or fermentation may be needed by wastewater deficient, carbon deficient. Phosphorus is removed by wasting PAOs. See, this is the flow chart. The influent, which is rich in phosphorus, which have to be removed after the secondary treatment, is passed through anaerobic reactor. So wastewater is exposed to the anaerobic reactor, then to the aeration tank. Understand? So if we keep on, if we do like this, anaerobic reactor followed by an aeration tank, definitely phosphorus accumulating bacteria the flourishes and it takes up a lot of phosphates from the wastewater, which are the phosphates which are present in the wastewater. Then it is taken to a clarifier. There in the clarifier, the microorganisms settle down. If we take the microorganisms out, it means that we are taking the phosphates out of the wastewater because most of the microorganisms has accumulated the phosphates in it around 20 to 30%, and whatever the effluent which comes out is free from phosphates. So it's a cyclic process of anaerobic and aerobic reactions will definitely leads to phosphate accumulating bacteria. Understand? And these are the bacteria that will remove the phosphates from the wastewater, and this is the flow chart. So these are the references that are used for this session.